Hi and welcome to this segment where we are going to summarize chapter 12 and chapter 13 in our resource book Basic Engineering Math by John Bird. So in here we are mainly looking at the solution of some of these equations by graphing. So if you look through the resource book, the procedure is not anything complicated. It's just that you get to know the equation which you're dealing with. For instance, let us start here with the quadratic equation here. So here, what we have here on the interface, on the screen, for those of you who are seeing it for the first time, is MATLAB. Okay, this is a computational tool which is quite popular in many educational institutions, especially for students of engineering or technology or science and so on. Okay, so it is, I think we have resolved, or I have resolved, that we shall use MATLAB. You can always pass by the computer lab and ask the person in charge to put for you the setup. I'm sure you'll find one there, or you can ask around students. I've seen quite many of them with this MATLAB here. So why I choose this is just for curiosity, for those who are interested and those who would like to learn something just beyond what is written for us in the course unit. So here we have the general form of the quadratic equation: x squared plus bx plus c equals to 0. And if we want to solve it by graphing, particularly let's pick up on an equation here: x squared plus 2x minus 8 equals to 0. Then all we need to do, like you'll see in the resource book, is just to create a simple table where you have values of x and then you have values of x squared plus 2x minus 8. Maybe if it is too long for you to compute at once, perhaps you can break it up into maybe x squared and then 2x minus 8, and then finally you get the value of, maybe you say y equals to the whole thing here, x squared plus 2x minus 8, and then to get the solution you simply plot x versus y. For each x you plot its corresponding y. You plug it in here, the value that you got by plugging it in here, then you plot x, you plot. Okay, so yeah, that is what is actually we are going to look at. But before that, I just wanted to write down something here simple for using the quadratic formula method. Last time we looked at the quadratic formula method and we said that all we need to know is the coefficients here. Of course, the coefficient a is 1, okay, and then the coefficient b here is positive 2, and then the coefficient c is negative 8. The constant c is negative 8. So we know that for the quadratic formula method it says that x equals to minus b plus or minus square root of b squared minus 4ac over 2a. So one value is the one which takes on the plus, and then the other is the one which takes on the negative. So this is quite very elementary and very simple, because we have to put in the values here straight away. But with time, some of you can write even much more fancier programs where you can put in inputs, where these can be inputs and you don't have to, you can create a function where these are taken as inputs. Okay, you can input them from your keyboard and then you just have the answer. So it is as simple as this. The syntax is quite easy to learn. The star here means times, and then division here, and then this is 2 times a, 2 times a. Then this semicolon here is simply to suppress. If I don't put it there, then it is going to write the output of this and then the output of that. So the semicolon here is just to suppress. I don't want the screen to write a as 1 and then b as 2 and so on. Okay, yeah, and then so it will compute x1. We declare x1 to be that one value. Okay, and then we declare x2 to be the other value, minus b minus square root of b squared minus 4ac over 2a. So let's run this and see what we get. Oops, I should have done that before, and I should have done this also before. Okay, maybe I'll just do this so that we can see it as it runs. So we run, and yes, here we are. we have the value of x1 is 2 and the value of x2 is 4. Surely you can substitute in either x is 2 or x is 4 in here and it should satisfy this. So it is just as simple as this. Okay, all right. Next is now we try to do the same but now with a graphical method. Oh, then the percentage signs here are just the program itself. If they are comments, okay, if I just want to write something that I don't want MATLAB to execute, I just add the percentage sign there. Those are comments. So if I comment everything and run, there's nothing that is going to show. Okay, maybe let me clear this so that so I can run, and all it brings back is script 1, or what I called my script here. Okay, but nothing. It shows no output. Alright, so now the next output, what you would like to run is this other part where I would like to solve the same equation here, the same equation, but graphically. Okay, so we would like to solve that, okay, by graphing. So I am going to remove the comments here because I wanted to run this one by one, and then I'll explain what everything here means. Okay. So the first one here, x equals to linspace negative 88. It is simply going, maybe let me remove that, remove the semicolon there to display it, and maybe comment that and run it, and then you'll see what it does. So you can just remove the semicolons and just run line by line and see. So what it does is that it outputs for us Linspace. What Linspace does is just that it gives us values ranging from negative 8, okay, with a particular interval or spacing up to positive 8 here. Okay, yep. So that is what it will do. There are many ways of running that, but that is, you can always check out help Linspace, or you can just Google it and see what exactly it does. So since this is our first, I don't want to go so much into detail. The first one is just that is Linspace, so it gives us values of x which we are going to use to plot. Oh, why should I do that? And then the next is that now for each value of x we now calculate y. Remember we say that for each value of x we plug it in here, x squared plus 2 times x minus 8. Okay, so someone will ask that maybe why do you have this? Now I'll explain this in a short while, maybe the subsequent videos, but the idea here is that since x, like you have seen, is a vector here, so when you say y equals to x squared, MATLAB may get confused, so you just put the dot here to specify that you're getting each value of x and you're squaring it. Okay, it's not the whole vector squared. It may not understand what to do with it, so it is just each value of x which is squared, then plus 2 times the value of x, that value of x, then minus 8. Okay, so the figure here is just that I wanted to plot each on a different figure, and then we plot x, y. So x is what these values here ranging from negative 8 to 8, and then y were the values of x which we are substituted into this equation here. So we substitute that, we plot that. The rest here, please don't mind about this. This is just some commands to set the axis locations at the origins. Okay, and then here this is just another command for the x label, and then the y label we want to call it y, and then the legend here is going to mark the axis, is going to mark the graph. We are going to mark it y is x squared plus 2x minus 8, and then this is going to be the title of the graph. Okay, then here, yeah, that's all, and then the title of the graph. Okay, so if we haven't made any mistake and we are good to go, we should, run this, and we should expect to get something nice. Okay, let me see. Yeah, still running, it's still running. Okay, yes, we have the output. Okay, So here we have the output. This is this is our graph here, and we see that it crosses the x-axis at 2 points here. You can clearly see that at here x is 2, okay, and here it crosses it at x equals to 4. So those are the two values, and we know graphically we plot, and where our curve cuts the x-axis, i.e. the line y is equals to 0, because we are simply plotting x squared plus 2x minus 8 equals to 0, meaning y is equals to 0. We just look for the point of intersection with the x-axis and clearly see that the point of intersection is at the points x is -4 and x is 2. Okay, alright, so let us try and run the next one here. So we will comment this, comment that, and then next we will try to solve the quadratic equation. Oh, we have now here, we want to solve the quadratic equation. Solve the quadratic equation for x squared plus 4x minus 15 is equals to 0, and this one here, you see this problem on page 97. So we could have done it just as we did this one here by just plotting it there, but I just wanted to show you something different. We can rearrange that equation and write it in the form 4x squared minus 4x squared equals to -4x plus 15, so that we plot now two curves. One will plot y equals to 4x squared, and then the other will plot y equals to -4x plus 15, and the point of intersection of these two curves, y1 is equals to 4x squared and y2 is equals to -x plus 15, is going to be the solution. Okay, so as usual, we are going to start with our x is equals to Linspace. You know what this is going to give us. It is going to give us equally spaced values for x between -4 and 4, and then we shall have one graph which we said we have. We are going to plot, that is 4x squared, and I hope you remember what I explained this means here. We are getting each value of x and then we are squaring it, and then the other is going to be 4x plus 15. Okay, but we will understand this one here, -4 times x. It will just get times each value of x in that vector. But if you're going to square it, you have to specify that it is each value of x which is squared. So that is why we add that dot here, okay, that point. And then the figure we will plot, I want to put it on a different figure here. Oh, maybe it makes sense. I put this because I was running this whole script at once, but since I decided that I'll run one by one, so it wouldn't have made sense. It doesn't change anything if I even if I remove this, since I am running everything one by one, so it is not much needed here. Then we plot here, we plot x, y versus y1, and then we plot x against the y2. So we know the values of x are these, and then y1 is going to represent for x squared, and then y2 is going to represent this. And then the idea is that the point of intersection of y1 and y2 is going to be our solution. So let us run this and see what we get. Yep, so we have something here. And maybe did I put the legend? I'm not sure. Oh no, maybe I forgot. Okay, forgot to put the legend. Oh yes, okay, I think I have to uncomment this and put the legends so that we can be aware. So this one is setting our x axis and y axis at the origin. We are calling the y label, the x label x, and then the y label we have y1 and y2, and then the legend is going to mark those curve graphs, which one is x squared, the parabola, or which one is the line for -4x plus 15, and then this is going to tell us the title. Okay, so we will save, and let me see, we will save that, and okay, we will save, and I have to, I'm not so sure why I have to here. We will save and try to run this. Okay, so yes, we have here, so we have the red line. The red one is the line y is equals to minus 4x plus 2, and then the blue is the parabola here, y is equals to 4x, and then the points of intersection here are going to give us the x values here. We will simply read off the x values here, and it looks like you can verify with what is in the book. Okay, so we have here, okay, yeah, we have here x value is like negative 2.5, something close to that, and the x value here is yeah, you can read off here and just put the pointer here. Okay, it is around 1.4, maybe around 1.5. okay, then you can check and see with what is in the notes. Okay, yes, and then see. Anyway, these are approximations here, since we are just solving this here graphically. Okay, so yeah, that is it. Then what else? Maybe we could try, let me see what else is there. Okay, yes, so we can also try to solve the cubic one. Okay, let us finish also the cubic one here, then we can go to the simultaneous equation. So here we want to solve, oh, let me first comment this maybe so that we don't run it. Remember I said we put the percentage signs here to tell MATLAB don't run whatever is there. Okay, so so we want to find the solution to the cubic equation by graphing. This is problem 8 on page 100, and that is the cubic equation which is on that page. And then now no prizes for guessing what all these are. X lin is equals x, I mean x is equals to Linspace equals spaced values for x between -4 and 4, and then we write our y, okay, 4 times x cubed minus a times x cubed minus 15 times x plus 9, and then I don't need that because I'm running each one by one. Then we put our plot. I want to plot the x-axis and the y-axis at the origin. You can always try commenting this and not running it, and then you'll see what will happen. Okay, then we have the y label, which you want to call y, and then I want to label the axis, I want to label the graphs. The first one is y is equals to 4. Okay, it's just one, sorry, so it is just that whole label. And then I want to put this title. Actually, this is not solving the quadratic equation, rather this is solving the cubic equation. So we save and we run, and yes, so we have solving the cubic equation by graphing, and then this is the legend. Okay, all right, this is the legend. Okay, I'll move it anywhere, and then yes, we can see this is our cubic equation here. So these are going to be the solutions. Okay, the x values. Okay, the x values here around -1.5, and then something there maybe around 0.5, and then something here around yeah, you can read off, you always just point maybe around 3, that is 3. So that will be the solution to this cubic equation by graphing. Okay, so we are going to comment this, and we look at lastly the solution to our quadratic equation. Okay, we are going to look at the solution to our no, not quadratic equation, rather simultaneous equation. So we'd like to solve our simultaneous equation here by graphing, and you know that the simultaneous equation, if it is linear, it's just the point of intersection of the two lines. Okay, okay, so we have one line is, one equation. The first equation is 2x minus y equals 4, and the second equation is x plus y equals to 5. So we know what Linspace is going to be here, our x-axis, the values on the x-axis, and then the one line, of course, you make y the subject from here, you make y the subject here, and then we plot the line 2x minus 4, and then from the next equation here, x plus y equals to 5, you make y the subject. So we just call it y1 and y2 to differentiate, and then we are going to plot x versus y1 and x versus y2, and then the rest here we know we set the x-axis, the x label, the y label, we put our legends to differentiate between these lines, and then again, I think I was just doing a copy and paste. This is not solving the quadratic equation by that, rather this is solving the simultaneous equation by graphing. Okay, so lastly let's run that and see. We expect two lines because both of the equations are straight lines, and then the point of intersection here, which is x is 2.99 and y is 2.0, roughly around x is 3 and y is 2, is the solution to our equation. So what I've shown you here is just using this MATLAB script. Okay, simple. We can always learn with time, and you can use them to automate some of these processes rather than drawing these by hand. Of course, drawing by hand you get the feeling of what you're supposed to do, but in practical sense it may not be very applicable. Okay, so you can also follow and do what is in the chapters 11 and 12, the way they have graphed them, and yes, and if you have any questions or any concerns, you can please put them in the comment section. Okay, thank you and see you in the next video.